So let us start this particular chapter, which we call it as fluid mechanics, isn't it? Yeah. So we'll go through the basic description, and then we will understand what is called as fluids or something like that. So first thing is we need to understand the difference between a solid and a fluid, isn't it? Means the question arises that what is a solid and what is a fluid basically. Okay. Now that's a biggest important point which we need to consider. So let's suppose if I'm considering a solid, then let's suppose if I have any kind of geometrical shape or something like that. Okay, let us consider that. 1 minute. Let us suppose that this is our solid over here, isn't it? And I'm considering a volume of I'm just considering a volume of fluid also, means a region of fluid. Okay. Now let's suppose this is our liquid. This is basically our liquid over here. Okay, I can fill it up. Let's suppose I fill it up with this shape. Okay, है कि नहीं? ऐसा मान लेते हैं फिलअप कर दिया है ना. तो ध्यान से देखो, मतलब प्रॉपर्टी समझते हैं इसकी, है क्या चीज़ ये फ्लूइड या है क्या चीज़ ये सॉलिड्स. तो पॉइंट क्या है कि मान लो अगर तुमने इसके ऊपर फोर्स लगाया, किस तरह का फोर्स? टेंजेंशियल फोर्स. इफ आई अप्लाई, इफ टेंजेंशियल, ठीक, on both the cases is basically applied in a solid kind of object also and on a fluid kind of object also. Okay, so I apply on both the cases or tangential force. Okay, so the concept is that when I apply this tangential force, you only tell me what should happen. Hmm. Can you tell me? Fluid solids gets fluid gets disturbed thoda sa. Okay, actually the thing is just opposite happens. Let's suppose if this is if tangential is applied, whenever we apply a tangential force, there are two kinds of forces. One we call it as perpendicular force, another one is called as tangential force. So when we consider the perpendicular force, we consider it as a pressure. क्या बोलते हैं उसको? प्रेशर के थ्रू बताते हैं. लेकिन जब हम टेंजेंशियल फोर्स बोलते हैं तो इसको हम बोलते हैं शियर स्ट्रेस. क्या बोलते हैं? Whenever we apply tangential force per unit surface area, we call this as shear stress. क्या बोलते हैं बेटा इसे? या ठीक है ना. तो मतलब थोड़ा बहुत अपन सॉलिड्स का भी काम कंप्लीट करेंगे, ठीक है ना. तो जैसे तुमने ये shear stress अप्लाई किया, लेट्स सपोज इफ यू अप्लाइड दिस shear stress, व्हाट विल हैपन एक्चुअली इज on this solid, this surface, means whatever this surface is there over here, it will actually deform, means it will actually shift till certain range on. Means what will happen, this will be just like if you think of a page of books and if you apply a tangential force, so what will happen, some of the top layers will get shifted but the other layers will never ever shift. Yeah. So if I consider, then I take in the example of fluids, what actually happens is if you apply this shear stress, you will see that this particular movement of the surface is continuously growing with time. क्या हो जाएगा? It will continuously change with respect to time. Are you able to get me or not? It's not going to be fixed. So basically, this is what is the biggest categorization of fluids. तो बोला गया fluids is nothing. Fluids is those kinds of substance, are those kind of substance या objects बोल सकते हो, which deforms, which deforms continuously with the application of, or under the application of, shear stress. You have to tell. under the application of shear stress. Is that clear or not? No matter how big or small this stress is, how big or small this stress is. Is that clear or not? मेरी बातें समझ में आ रही हैं? What are solids then? So basically, they will not deform continuously. Simple सी बात है. Continuously, they will deform, but there will be not a continuous deformation. It will stop over here. Is that clear or not? After this deformation, there is no such deformation. But what we will see that over here the deformation is continuously increasing, 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 and so on. Are you able to get me or not? So solids are those kind of objects in which the shear stress is there. There is a deformation, but that deformation will not grow after some time. But in fluids, the deformation grows after some time. Is that clear or not? Are you able to get me? So the question arises that if I am considering a fluid, so whatever fluid if I consider, then the fluid should have some property, isn't it? So basically, to start with the physics, since we can't consider any kind of a fluid, we process the whole physics through a concept called as ideal fluid. क्या चीज के थ्रू बताते हैं अपन? So basically, we describe this whole concept. Yeah. So basically, this is not perfectly possible, but still we consider it. ठीक है. तो क्वेश्चन क्या आता है कि बेटा ये आइडियल फ्लूइड्स होते क्या हैं कि नहीं? तो बोला गया कि आइडियल फ्लूइड्स आर दोज काइंड ऑफ फ्लूइड्स व्हिच आर बेसिकली इनकम्प्रेसिबल इन नेचर. क्या नेचर होता है पहले तो basically what is the meaning of that? That means you can't compress the ideal fluid. If I can't compress the ideal fluid, that means what? The density of the fluid always remain constant or not? Yes. So simple सी बात है. Whatever variation is there in the pressure, whatever variation in pressure is brought, the shape of fluid does not change. Sorry, the density of fluid not does not change. The density of fluid does not change. Are you able to get me or not? Is that clear? Is that clear? Next point, since this is first point. The second point of the means a particular ideal fluid is that it is non-viscous in nature. कैसा nature रहेगा? Now this is a new term. Actually, we will understand about this non-viscous term in a many. Basically, what happens is that we think that a fluid is also a kind of thing. Any kind of a liquid is not perfectly, basically, a perfect liquid. It's also there, just like in solids, we can have different layers and all. So similarly, for a fluid also, it is thought that we have a layers. We do not have perfect fluids or something like that. Is that clear or not? Okay, so basically there are layers of distribution in the fluid. Just like you can imagine like a book. एक book की तरह हम imagine कर सकते हैं. Is that clear or not? Yeah, pages of the books. So basically, just like a book is a bundle of pages, similarly, a fluid is a bundle of different layers. So if there is means if those layers are not creating any kind of contact force, then we call those kind of layers as non-viscous layers. क्या बोलेंगे उसको? So basically, in fluid, for ideal fluid, the layers should be non-viscous. That means the tangential contact force uh, within the layers of fluid is zero. Is almost negligible issue, right? Is that clear or not? हम्म मेरी बातें समझ में आई. Third point, basically it is wrote, it is we were one means this is we can understand right now itself, but these two properties have a detailed discussion. And the third property is that all the fluids are streamlined in nature. Which kind of nature they have? This means that whatever happens, the fluid have a particular kind of a flow. क्या रहता है बेटा? Yeah, means they move in such a way that they have a particular direction of a flow at any random instant of time. Are you able to get me or not? These lines will never ever intersect. Means you can feel like all the layers have a different velocities and they are never ever intersecting with each other. Are you able to get me or not? So the ideal fluid has three properties: incompressible, non-viscous, and streamlined. Means moving in a perfect direction of a flow. Are you able to get me or not? Yes. Now, if we are discussing fluids, then the point arises that we need to first physical quantity which needs to be discussed is the density of fluid itself. What we need to discuss? Density. Okay. So you know that in simple case the density is given as mass by volume. Yeah, but you can't understand density until and unless there is a particular kind of a measurement. Yeah, basically the point is simple that we can't do anything until and unless there is a particular reference of the density, isn't it? So that is why we define one of the important property which we call it as also by the name of relative density. क्या बोलते हैं इसे अपन? So relative density is given as density of substance by density of water at 4 degrees centigrade. Yeah, why 4 degree? You will get to understand in thermal physics why 4 degree at 4 degree centigrade. Are you able to get me or not? So we have a reference frame of density. You can't understand density until unless you have a reference frame, isn't it? जैसे मान लो अगर कोई एक मोटा व्यक्ति है, पतला व्यक्ति है, तो हम कैसे मोटा कैसे बोलते हैं? हम दूसरे को कंपैरिजन के करके ही बताते हैं ना कि हाँ ये भाई ये पर्सन मोटा है. हाँ, तो वो फैटनेस कैसे बता पाते हो? Until unless you will not compare, you will not be able to get it, isn't it? So similarly, density is also there. We need to compare it and then we can understand it. Are you able to get me or not? Yeah, it's a relative term basically. That's what I told you, that's why we defined the concept of a relative density. Are you able to get me or not? Now the point is very very simple that I can the point is जैसे एक दूध वाले को देखा होगा तुमने. दूध वाला क्या करता है? Milkman, what does he does? He mixes water and milk with each other or not? Yes, similarly I can mix oil and water also or not. So you can have a mixture of two or more liquids, isn't it? So let's suppose I want to mix two liquids. So I consider the first case of that. I'm mixing two liquids, right or not, in such a way that the two liquids have the density rho 1 and rho 2. Okay, they have the densities rho 1 and rho 2, and their masses are also given m1 and m2. So if I mix them together, then what is the total density of the mixture which I will find out? That's a big question or not? Yes. So can you tell me what can be the density of the mixture? How come we can know that? See, we can't do that in a simple. Basically, simple सी बात है. ध्यान से देखना. बोलता है कि हमें मालूम है सर कि कोई भी डेंसिटी हो तो डेंसिटी इज इक्वल टू टोटल मास बाय टोटल वॉल्यूम, isn't it? If I mix together also, it does not changes anything with the formula, isn't it? So look over here. So density of the mixture, total mass is known to us, which is m1 plus M2. But do we know about our total volume? No. So total volume is what? V1 plus V2, isn't it? But what is V1? Mass M1 by density rho 1, isn't it? Similarly, mass M2 by density rho 2. Are you able to get me or not? So therefore, density of mixture when masses are known to us is given as M1 plus M2 into rho 1 into rho 2 divided by M1 rho 2 plus rho 1 M. Are you able to get me or not? Is that clear? Similarly, I can consider the another case where liquids densities are mentioned, but this time volumes are mentioned. So then once again, you are required to find the density of mixture. So once again, I'll get the same formula, total mass by total वॉल्यूम. अरे कुछ तो बोलो, हाँ है ना, यही होगा ना. यस. तो टोटल मास तो हमें मालूम नहीं है ना, बट हमें क्या पता है, वॉल्यूम पता है. तो मास इज इक्वल टू डेंसिटी इनटू वॉल्यूम. सो व्हाट आई विल गेट, so it will be you can directly write the formula. Density of mixture is nothing but rho 1 v1, this is mass m1, plus rho 2 v2, this is mass m2, divided by total volume, which is v1 plus v2. Is that clear or not? So we got to define many things. Like if I am considering fluids, the first categorization was the understanding of difference between solid and a fluid, and then the description of an ideal fluid, and then the description if I mix two different fluids, then what will happen. Now, right now you got to know that here we need to consider the tangential forces which are present on the surface areas, isn't it? Or some kind of a force which is present on the surface area. So the concept was basically that if I'm defining force perpendicular to the surface area, then why not define the pressure for that, isn't it? So basically, we got the idea to define now pressure and all these kind of quantities. Are you able to get me? So let us define one of the important physical property which we call it as pressure. क्या चीज बोलते हैं बेटा इसको? प्रेशर है कि नहीं? कुछ बताओ. What is pressure? You have studied so much. Force by. That's all. That's my pressure only. What is the physical meaning of pressure? Can you explain? But that's the mathematical description, no? Uh-huh. So basically, that's the mathematical description only. So what is then this pressure is? Now try to understand what is this pressure. अच्छा मान लो बेटा कोई भी फ्लूइड है ना. I'm considering a region of a fluid, okay? Got it. I'm just considering a region of a fluid. Now you see that when I consider this region will have some surface area, isn't it? Try to think of one case that when I'm considering this region, I consider the surface area of this region to be dA. क्या माना है इसे? तो मान लेते हैं कि means it was like some kind of a gas chamber or a volume chamber or something like that in which it was contained. Are you able to get me or not? Now look over here. Let's suppose if I have any kind of a fluid or any kind of a gas which is at rest basically. कैसा है? So let's suppose when we have a fluid or gas at rest initially. कैसा है, रेस्ट पे. But you think of one case, the particles of fluids are not at rest, no? The particles of gases are not at rest. So basically, what actually happens is that this fluid starts to generate some kind of force which will be perpendicular to the surface area or not. This fluids will apply some kind of force which will be perpendicular to surface area, isn't it? Basically this is due to the fluid which is at rest. Yes, you can consider even particles. मतलब particles नहीं बोल सकते, ऐसे बोल सकते हैं कि सर जैसे हम फ्लूइड रख दिए तो फ्लूइड का काम क्या है, फैलना. फ्लूइड का काम क्या है, स्प्रेड करना, है ना. सो दैट इज व्हाई दे अप्लाई द परपेंडिकुलर फोर्स टू द सरफेस एरिया, है कि नहीं. Yes. So biggest means that is one of the reason, and why that is getting scattered is basically simple सी बात है कि the fluid particles, fluids or gases particles are always in random motion. किस मोशन में रहते हैं. So this is one of the another reason to apply this perpendicular force, isn't it. So look over there, this fluids which has the particles or gases which are present in always the random motion, they starts to apply this perpendicular force by colliding on the walls of the container or anything. Is that clear or not. Now, the point is simple that if we are just imagining any kind of a perpendicular surface area inside the fluid, जैसे हमने कोई एक इमेजिन कर लिया है ना, तो बात क्या है कि सिंपल सी बात है कि सर अगर रैंडम मोशन में है लेकिन फिर भी फ्लूइड अपन का रेस्ट में है ना, तो एक्चुअली में होता क्या है कि ये जो फोर्स इधर से लगा उसका सेम एक इक्विवेलेंट इक्वल एंड अपोजिट रिएक्शन क्या होता है फ्रॉम द कंटेनर वॉल्स इट अप्लाइज. इज दैट क्लियर और नॉट. इज दैट क्लियर. So this application of perpendicular forces is in this way. Means if the we can see if the fluid is at rest, then the forces are, yeah, forces are balanced out as the force from the other side and the force from the another side. Is that clear? Or not? Although the particles are in which kind of a motion? Random motion. Are you able to get me? ठीक है. So this is why this perpendicular force which is generated or which is applied with respect to the surface area, we told that this thing needs to be constant from both the sides. Means the area also needs to be constant and force also needs to be constant. So this was the idea to bring the new physical quantity which we defined as pressure. क्या define किया? Pressure. And we told that pressure is nothing but the force perpendicular per unit area. Are you able to get me or not? But that's a mathematical description. Are you able to get me? So what is pressure? It's nothing but it's a new physical quantity which was brought to us to understand that how the fluids, although having random motion of the particles, is at rest. Are you able to get me or not? Because we know that the fluid is always trying to flow, isn't it. But we are confining it. So if we are confining it, it must apply some kind of force which must be balanced. But that also depends upon the area length of the surface on which the fluid is present. Are you able to get me or not. Is that clear? So basically, that's how we define the pressure as force perpendicular, because we know that fluid has, लिख लो फ्लूइड, सिंपल सी बात है कि द एबिलिटी टू फ्लो makes a fluid unable to sustain unable to sustain a force parallel to the surface, isn't it. So under a static condition, under static condition, what happens? The force component, the force component uh, normal to the surface area is considered, which which generates the flow. ठीक है? क्या है कि फ्लूइड के पास हरदम क्या है बेटा, एबिलिटी है मूव करने का, अगर तुमने कोई फोर्स लगा दिया है कि नहीं। तो पॉइंट क्या है कि जो ये फोर्स लग रहा है वो फोर्स की डायरेक्शन कैसी है, हरदम परपेंडिकुलर टू द सरफेस एरिया, एंड दैट इज व्हाई वी डिफाइन, since this particular surface has started now to move, that's why we define the pressure, which is for force perpendicular to surface area divided by area. Are you able to get me or not? And that is why the force, basically, if force is constant throughout the area, pressure is defined as normally force by area. Although try to see that force is a vector quantity, area is also a vector quantity, but my pressure is a scalar quantity. Which kind of quantity is pressure? Scalar. The reason for that is the pressure is nothing but it is present in all the directions for all the particles at one point. Is that clear or not? So that is why it is called as a scalar quantity. Are you able to get me or not? So definitely, let's say if I want to define unit of pressure, it is given as Newton per meter square. इसको बोला गया पास्कल. क्या बोला गया? Pascal. And basically, as we know that every body is feeling some kind of pressure of the atmosphere on us, so we define one atmospheric pressure out of that, and which was equal to 10 to the power of 5 pascals, or 10 to the power of 5 newton per meter. Yeah, is that clear? Are you able to get me? चलो लिख लो इसको, फिर अपना पढ़ेंगे. Okay, now then the question arises, just only pressure is present or what? But there is no, there is one more quantity which needs to be addressed, and that is called as thrust. ठीक है, isn't it? So what is thrust? Can you tell me? हाँ, हाँ, हाँ. Tell me what is thrust? It's easy. Think what you have studied. Can you define thrust? It's easy. You just think. अच्छा मान लो एक कंटेनर में एक लिक्विड भर दिया है ना, एक सिलेंड्रिकल कंटेनर लिया, उसके अंदर एक लिक्विड भर दी, और इसके अंदर मैंने एक स्फेरिकल बॉल को क्या कर दिया, ड्रॉप कर दिया. ओके, what will happen with this spherical ball? Level of the fluids will change. I'm not considering about the level. Think of the forces on this ball. So what will happen with this ball? If you drop in this liquid, what will happen? This ball, this ball will feel the force from each and every side or not, due to the random motion of the particles, isn't it? So basically, thrust is similar to pressure, but it has a different meaning. Basically, in water, inside the water, there is no pressure which is applied. the pressure, the basically you can say the pressure is applied, but the point is, since this pressure is present from all the directions, that's why we call it as thrust. So basically, it is nothing but a total force present or exerted by the liquid on any surface, on any surface in contact with it. ठीक है? Simple. What is thrust? It's nothing but the total amount of force which will be exerted by any kind of uh, we, yeah. So basically, it's like the pressure into area. You can't say something like force. So the point is, as we know that uh, बेसिकली बहुत लोग सोचते हैं ना, यही यही दिक्कत आती है कि थ्रस्ट को लोग प्रेशर का नाम देते हैं। क्या नाम देते हैं? प्रेशर। बट yeah, but pressure is force by area, isn't it? But here, thrust is not force by area. Thrust is just the calculation of force. Are you able to get me or not? But the point is, this force, since in it, if we consider any kind of a surface in the liquid, this force will be present from all the directions. It does not have a particular direction. Are you able to get me or not? So that is why to make that force to be a scalar, we call it as thrust. What we call it as? Is that clear or not? So basically, thrust is the total force exerted by the liquid on any kind of a surface which is in contact with it. Are you able to get me or not? Is that clear? So this is our two important things which we need to understand. One is called as pressure, another one is called as thrust. Are you able to get me or not? Then now you try to understand that let's suppose if I have any kind of a container and then one minute, and in this container, let's suppose if I fill up some liquid, isn't it? And if you see over there, that let's suppose if you let's suppose if I drop a person from here, okay. So whatever he is feeling in this atmosphere, he will feel the atmospheric pressure or not? He will feel what? Atmospheric pressure, which we call it as P naught. What we call it as? P naught. But when he goes inside, he will find out. देखना जब पानी के अंदर जाते हैं तो हमारा सांस फूलने लगता है, बोलते हैं ना कि हमारी चेस्ट फूल जाती है कि नहीं? So that means if I go inside, my pressure has got increased, isn't it? You can also take an example of divers. You know that one. Do you know that uh, like if I consider any kind of जैसे मान लो मतलब मैंने से अगर सेलेक्ट किया कि डाइवर्स जो जाते हैं, जो डाइवर्स पानी के अंदर जंप मारते हैं, तो जब वो जंप मारते हैं ना, तो सुना होगा तुमने वो ऑक्सीजन के साथ हीलियम का भी सिलेंडर लेकर जाते हैं। कौन सा सिलेंडर? हीलियम गैस का। Why they take the helium gas cylinder? Basically, if I consider a diver, you will see that the diver contains two kinds of cylinder. One is oxygen gas, another one is helium gas. Why they take the helium gas cylinder? This is the reason that when they come to the inner, means the depth of this liquid surface, they found out that when they are going down and down, they are feeling extra pressure due to the liquid present above them. So the pressure over here got increased. Pressure क्या हो गया यहाँ पे? Increase. मान लो यहाँ पे प्रेशर क्या हो गया बेटा? P डैश क्या हो गया? तो इस प्रेशर के वजह से क्या होता है? तुम्हारे बॉडी के ऊपर बहुत ज्यादा प्रेशर पड़ेगा ना, और ब्लड को बहुत ज्यादा पंप करना पड़ेगा. So they inflate the whole system, whole body thing with the helium gas cylinder, which actually decreases the pressure. तुम्हें मालूम है ना, helium has a very less pressure gas, isn't it? So basically, that provides us that condition to sustain that extra pressure provided by the liquid surface. Are you able to get me or not? And from here only, the concept of one of the most important thing which we call it as absolute pressure and gauge pressure comes over there. Are you able to get me or not? So look over here. You find out that here my P dash pressure is present. Here atmospheric pressure was present. So if I go down, I have some excess pressure or not? This excess pressure can be written as the P dash minus P naught, which is ATM atmospheric pressure, isn't it? Basically, this excess pressure which is present above atmospheric pressure is called as gauge pressure. क्या बोलते हैं इसे अपन? What is gauge pressure? See, अरे बाबा means out of atmospheric pressure I have some extra pressure over here or not? So the extra pressure which is present apart from atmospheric pressure is called as gauge pressure. And here I have a totally different pressure or not? So we call it as absolute pressure. क्या बोलते हैं इसे अपन? P dash as, are you able to get me or not? So absolute pressure is that pressure which is present at any random point, but it can be either less than atmospheric pressure. It will never be. Is it possible to make it less than atmospheric pressure? We do not know. Yes, sometimes it is possible to make less than the atmospheric pressure. So the gauge pressure can. Uh-huh. Yeah. Usually it's more. So that is why we define that whatever the excess pressure is present apart from atmospheric pressure, that amount of excess pressure is called as gauge pressure. क्या बोलते हैं इसे अपन? Are you able to get me or not? So remember that absolute pressure is always greater than atmospheric pressure, is always greater than or equal to atmospheric pressure atmospheric pressure. But there are certain conditions also where some exceptions are there, where even the absolute pressure can be also zero. Yeah, is that clear? So absolute pressure can be zero, equal, या फिर greater. But the gauge pressure can be anything. It can be positive also, it can be negative also, and it can be zero. Is that clear? Are you able to get me? Understood totally now? So any kind of doubt till now? No. Okay, now look over here. So let us understand one of the most important thing regarding the understanding of. 1 minute, do we have hexagon shapes over here? Yes. Hmm, not this way. Let me delete it. Let's suppose I have a container in such a shape. Okay, and I fill it up with some water. Some water is filled over here. Void or not? So I fill this container with the water, isn't it? So what happens is actually whenever if I fill this with some kind of water till some levels or something like that, you will find out that basically these waters are applying some kind of force on the wall, isn't it? These liquid surfaces are applying some kind of force on the wall. perpendicular to the wall, and as this liquid is still at rest over here, it means that the wall is also applying some kind of force on the liquid, isn't it? Like this wall is also to balance. Yeah. So the point is simple that these forces which is applied by liquid on any of the wall surface is basically same. Is basically what? Same in magnitude. And similarly, the force applied by the container of the walls also is same from each and every side. Are you able to get me or not? So let's suppose if I write red one as the force applied by water on wall container, and black one represents force applied by water, sorry यहाँ पे liquid लिख लो, force applied by wall on liquid. So you will find that each and every point, if this liquid is rest in nature, कैसा है liquid बेटा? रेस्ट में है ना? तो इसका मतलब ये हुआ that these both all the combination of force at each and every point is basically what? Same in nature. कैसा है हरदम? Equal and opposite. Are you able to get me or not? Now, right now we got to know that we have a variation of pressure as we start to go down and down and down and down. So this brought us the concept that what can be the pressure at any random height or not, isn't it? है कि नहीं? तो अपन हेडिंग डाल दो वेरिएशन ऑफ प्रेशर विद रिस्पेक्ट टू हाइट एंड वी आर गोइंग टू स्टार्ट दैट. ठीक है. So let's suppose this was our container and which I have filled up with some kind of a liquid, means these are the walls of the container, and I filled up with some kind of a liquid where the liquid has density rho. Density of liquid is given as how much? Rho. The question arises that if I consider any kind of let's suppose this is my water surface level. Okay. This is my water surface level. Okay. So let's suppose irrespective of mass which is dipped over here, I want to know that what can be the change in pressure if I go at such a depth d below, isn't it? We need to find it. Are you able to get me or not? So you know that on this upper surface, whatever is this upper surface over here, this upper surface has same value of pressure at each and every point since it is in contact with the air. The atmospheric pressure is present over that or not. So remember that any surface in contact with air, any surface in contact with atmosphere fills atmospheric pressure. क्या fill करता है बेटा? Are you able to get me or not? So now over here at depth d, I have another pressure P dash or not? The point is, I want to calculate what is this pressure P dash at depth d. Are you able to get me or not? Let us suppose this, if this is point A and this I call this as point B, and I then I can find the pressure at point A. I know the pressure is P naught, isn't it? Which is equal to atmospheric pressure. But the question arises, what is the pressure at P, isn't it? How to find that? That's the biggest question or not? So, can you tell me how to find that? Try. अच्छा ध्यान से. So how to find that? To find that, basically, we process a easy tray that we consider a liquid element over here. कौन सी element? Is that clear? What kind of element we are considering? Liquid element which has some length. I call this length to be dx. I call this length to be how much? Dx, which is located at some random height x. So some random depth x. Are you able to get me or not? Okay. So try to understand that if I want to find the pressure on this liquid, I need to at least know about the forces which are present or the free body diagram of this liquid element or not. So let's suppose its length is dx. So from the top surface, these liquid surfaces which are present, they will apply some force over there, isn't it? कुछ तो बोलो हाँ या ना. तो मान लो ऊपर से जो फोर्स पड़ रही है इस सरफेस के ऊपर, मान लो वो फोर्स कैसे इसके बराबर होगा? ड्यू टू द लिक्विड देयर इज प्रेशर व्हिच इज प्रेजेंट, सो आई कॉल दिस एज फोर्स एज प्रेशर इनटू सरफेस एरिया ऑफ द लिक्विड एलिमेंट. आर यू एबल टू गेट मी आउट? सिंपली, अरे बाबा एक बात बताओ, व्हाट इज फोर्स? फोर्स इज इक्वल टू प्रेशर इनटू एरिया और नॉट? तो सिंपल सी बात है, ऊपर लिक्विड सरफेस है तो वो फोर्स अप्लाई करेगा कितना, जितना प्रेशर इनटू एरिया होगा वही ना. Okay. Now for this pressure into area, there will be equal and opposite reaction. Same pressure into area, isn't it? But you think of one case, due to the weight of this liquid, due to the weight of this element also, there will be an extra force which will be present downwards or not, which will generate extra a small pressure upwards dp into area. Are you able to get me or not? So since this liquid is not moving, the net force PA plus dp into area A minus PA from top must be equal to 0, isn't it? Sorry. Not be equal to 0. It must be equal to minus, sorry. I forgot one thing. Minus PA. The weight is also there, no? dm into gravity Z. Minus dm into gravity Z must be equal to how much? 0. Excess press. I'm not considering excess pressure over here. I'm just writing the force equation. We know that this element is not moving, so net force is equal to how much? 0. So this implies the upward force minus downward force equal to how much? 0. Is that clear or not? Okay. So you see that this and this got cancelled. I'm left out with dp into area A is equal to dm into gravity G. यही होगा ना? So what is uh, dm? dm is equal to mass density into volume. अब लिक्विड की डेंसिटी कितनी है? रो. So rho into volume is area into height dx into gravity g. So look over there, dp into area a also get cancelled. What I got as equation, that dp is equal to rho dx into gravity g. And I need to do this integration because I have to find at any random height or not. So the variation of pressure happens from where? Basically, I want to find pressure at point B, but I'm coming from point A or not. So the integration must be taken from A. At A, height is 0. At B, the depth is D or not. So basically, equation becomes what? P at B minus P at A is equal to rho G is constant. So rho G into depth. The integration of dx is just x. So rho z d. Is that clear? Are you able to get me or not? Now pressure at A is the atmospheric pressure P naught. So this equation can be still further resolved and can be written as pressure at any random depth is nothing but atmospheric pressure plus the pressure provided by the upward liquid over that point. Are you able to get me or not? अरे बाबा सिंपल सी बात है पीए की वैल्यू क्या है पी नॉट के बराबर है ना इज दैट क्लियर अंडरस्टूड मेरी बातें समझ में आ रही है नहीं आ रही so that means you see that when I talk about this variation of pressure so try to see pressure at any depth is equal to P naught plus rho g d. Are you able to get me or not? Where this means that P naught is a constant. So if I see how pressure is varying with respect to depth, so pressure at any random depth is directly proportional to depth. Means as the depth increases, pressure is also increasing, isn't it? Yeah. So when I draw the graph of pressure versus depth, then total pressure is never ever zero, isn't it? It always minimum pressure at any random height is P naught. So after P naught, the graph will vary linearly, isn't it? So this is the value of P naught and in depth it is P naught plus rho ZD. Are you able to get me or not? Okay. Next property is let's suppose if I take uh, let's suppose if I suddenly take ऐसे मान लो एक अपन ने एक वाटर कॉलम बना लिया है ना इस तरह कुछ इस तरह है ना और इसके अंदर भर दी लिक्विड बाय क्या कर दिया अपन ने लिक्विड को भर देंगे है ना so look over here. The pressure, you can see that pressure variation is independent of shape and size of liquid or not. It's just varying with respect to depth, isn't it? So that means, like, if I select any of the horizontal level over here, in somewhere over here or something like that, anywhere, if I just consider it, this means what? If I select any horizontal level, since pressure is independent of shape and size, the pressure at any point of this horizontal level is going to be same or not? So let's suppose if I selected point A and if I selected point B, you will find that the pressure at A as pressure at B because both are present at same depth D. Are you able to get me or not from that topmost point? Is that clear? The depth is basically same. Is that clear or not? So simple. If the concept is the second property of this variation of pressure is that the pressure is same at any point at any point of same level of same liquid irrespective of geometrical irrespective of geometrical uh, geometrical shape of container basically okay independent of geometrical shape of container are you able to get me or not understood so till now we concluded so many points regarding ideal fluids and all variation of pressure, then thrust, then gauge pressure, atmospheric pressure, then variation of pressure and then the property related to pressure, isn't it? So there was one intelligent scientist. He thought, why not? As we know that pressure at any level is same. So he thought that let's suppose if I increase some pressure over here by some amount, okay, then as the pressure at any level should be same, then this much amount of the same pressure must be thrown out over here at point B or not. Yes, yes. So this was actually called as this concept was brought by a scientist called as Pascal, and we call it as Pascal's law. क्या बोलते हैं इसे अपन? Yeah. What we call it as Pascal's, क्या है ना? चलो, till now is this clear? Any kind of doubt till now? Yes. So can you explain me what is Pascal's law? Mm-hmm. Any idea? So he told one important point. He told if the pressure of liquid is changed at any point at पहले particular point पे लिख लेते हैं at particular point at a particular point, then that change is transmitted to the entire liquid without being dismissed in magnitudes, without being diminished. Yeah. Hmm. Is that clear or not? Are you able to get me? So the point is very, very simple. That suppose if I have any kind of a container, okay, and I have some liquid surface over here, then we know that let's suppose if this is point A and this is point B, okay, and the difference between point A and B is height h, okay, then we know that at A is in contact with the air, so pressure at A is P naught. है कि नहीं? Pressure at B is exactly written as rho gh, है ना? तो मान लो if we increase the pressure at point A by P dash, मान लो मैंने point A पे increase कर दिया pressure by how much? P dash, then the same amount of pressure will be transmitted at point B, and therefore हाँ P dash plus rho gh. Is that clear or not? मेरी बातें समझ में आ रही हैं? Is this totally clear? So Pascal was able to, based upon this, the Pascal was able to define one of the most important physical application of the physics till now, which we call it as hydraulic lifts. You see the car, brakes, everything is based upon Pascal's law. Yeah. So basically, Pascal and Archimedes was called as the father of application physics. क्या बोला गया? Father of application physics बोला जाता है उनको, है ना? Hmm. So what was his idea? Simple. अब देखो, मान लो अगर मैं बन गया रोमन रेंज, क्या बन गया? तो मतलब मान लो अगर मैं फ्यूचर में रोमन रेंज बन जाता हूँ, मैंने बहुत एक्सरसाइज किया एंड आई बिकेम रोमन रेंज, सो आई कैन पुल अ ट्रक इजीली, इजंट इट? बट स्टिल आई कांट लिफ्ट अप द ट्रक ना. But you can see when you go for a servicing or something like that, they lift up the car by that much height, isn't it? So that is not possible if we do not use the physics. So basically, that's the best example of physics. How do we utilize it? What they do is very simple idea they apply. They tell that let us use physics over here, and the physics is very simple. How they do it is also very simple. They just use the principle of Pascal. How? We know that. Let's suppose मान लो ये एक रीजन है और यहाँ पर उन्होंने वो बड़े वाले सरफेस एरिया पे प्लेटफॉर्म बना देते हैं. क्या बना देते हैं? हाँ, ठीक है. और यहाँ पे भी पिस्टन कुछ लगा देते हैं. ओके. अब बोलते हैं कि और इसके अंदर वो एक बहुत अच्छा सा इनकॉम्प्रेसिबल लिक्विड लगाते हैं, बहुत ही अच्छा. ठीक है. Of course, incompressible. Always you have to take the fluid as incompressible, isn't it? What? Of course, the things will change. Of course, for that, the things will change, isn't it? But we do not have to study the compressible one. Okay, we do not have to study the compressible one. So now let us consider that we have a geometrical shape of like this way with two piston attached and in between it some kind of a liquid is filled up having density rho, जिसकी density कितनी हो? Rho. और एरिया ऑफ क्रॉस सेक्शन दिया हुआ है A1 और A2, है कि नहीं? तो बोला कि लेट सपोज यहाँ पर एक बहुत हेवी मास रख दिया. क्या रख दिया बेटा? है ना? या काइंड ऑफ दैट. So look over there. This mass will generate a force of mg downwards or not, and that mg will be very high. But I need to balance it. So if I want to lift it up, we will not be able to lift it. But this liquid can help you. How it will be helping you? Because we know that if I attach the liquid in this container, this force has been changed into pressure. क्या चेंज हो गया ये force? प्रेशर. और प्रेशर को तो बैलेंस करना आसान है ना. क्यों? क्योंकि प्रेशर सिर्फ फोर्स पे डिपेंड नहीं करता है. प्रेशर क्या इसके ऊपर डिपेंड करता है? एरिया पे भी. क्या इसके ऊपर? एरिया. Yeah, so they brought this concept that let's suppose if this is applying some mg, then I need to balance it. So I'll do what? I'll apply some force F1 over it. Is that clear or not? So simple, we can know that whatever pressure. So look over here, there is a extra pressure which is present, isn't it? Apart from the atmospheric pressure. So pressure at exerted at the left side is given as how much? Simple, it is equal to pressure 1. I call it as pressure 1, which is force 1 by area A1. And I'm ignoring the atmospheric pressure. I'm ignoring what? Atmospheric pressure. Are you able to get me or not? because both are same over here and here, na man. So that will get cancelled. Okay. Similarly, now you can think that this body, I want to lift this body, isn't it? So this on the right hand side, there is a pressure which is also applied. So pressure exerted at right side is equal to P2, and that will be equal to the force which is mg by area of cross section A2 or not. Yes, this is my P2, isn't it? Now the point is simple. If I want to balance, you know that the pressure transfer should be same if the fluid is static. Fluid कैसा है बेटा? Static है कि नहीं? The pressure at both the levels will be same. That means P1 is equal to how much? P2. Ideally, because we know that at any random same level the pressure is what? Same over there or not? Right now we proved it. Not, but also it can be also same over at any level. It's not only depth. At any horizontal level the pressure is same, isn't it? So look over there. If I consider P1 is equal to P2, then I can write simply F1 by area A1 is equal to mg by area A2, है कि नहीं? तो ध्यान से देखो बेटा, we got one idea that the amount of force that needs to be applied mg A1 by A2, है कि नहीं? है ना? ना ध्यान से देखो, A2 is bigger than A1 or not? So if A2 is bigger than A1, the force required F1 will be less than the original value or not? तो जो तुम्हें फोर्स लगाना था उसको लिफ्ट अप करने के लिए फोर्स घट गया या नहीं घट गया? एक्चुअली में घट गया ना. सो दैट इज व्हाई, या सो बेसिकली सिंपल सी बात है. दिस मेक्स द mg, दिस implies mg is too much greater f1, isn't it? So that is why. But since it can be balanced using the Pascal law, so the amount of force that needs to be applied is how much? mg1 by a2. Are you able to get me or not? Where a2 needs to be a bigger cross section and a1 needs to be a smaller cross section. Is that clear or not? ठीक है, आगे बढ़े. Now what happens? Now you know that means if the liquid is there, then there are some pressure differences at each and every point, isn't it? So then now these bodies were at rest, isn't it? Now I can fill up a container. I can even accelerate the container or not. So pressure variation with respect to second case with respect to due to acceleration. ठीक है. पहले प्रेशर वेरिएशन विद रिस्पेक्ट टू हाइट पढ़ लिया है ना. अब क्या चीज के थ्रू पढ़ेंगे? Acceleration. So let's suppose if I have a container and I filled up this container with some kind of a liquid, and this container is moving with acceleration a. Okay, I do not know. Then you have some random points A and B. So you only tell me where will be the pressure high, at B or A? Pressure will be high at B or A. Hmm. Tell me where will be the pressure high, B or A? इमेजिन नहीं करते हो कुछ. अबे यार एक बार अगर मान लो एक पेंडुलम है, लेट्स सपोज इफ आई एम कंसीडरिंग अ पेंडुलम kept in a truck and I made the truck to accelerate. The pendulum goes backwards or not? Because force is applied where? Backwards. So where pressure is high? Due to the backward force, the pendulum moves backwards or not? So if the force at B is more, so where the force will be more? B or A? If the body is accelerating, where will be the force more? A or B? A. A will be the force more. Huh? Achha, this liquid will move towards which side? If I accelerate the body towards right or left? Liquid is going to move towards left. So where is my force? High. Left or right? Left it is high because the liquid is going to move towards left or not. So pressure at B is high, isn't it? So my question is, find this pressure difference. Find this pressure difference. Do it. Where will the pressure high? You know that at B it is high. Then find the pressure difference. Can you find the pressure difference? What will be it? Mm-hmm. Mm-hmm. Tell me how much is that? Mhm. Only the pseudo force is acting, yes? Yeah, only the pseudo force will only act, isn't it? Mm-hmm. Acha, ध्यान से देखो. We know that the pressure difference is generated due to the pseudo force, है कि नहीं? तो भाई कुछ भी हो जाए, full fluid is still at rest or not? बस this is the only concept, legitimate concept. Consider any element. Okay. Yeah, and from here to here, length to be L. The length gap between A to B is L. Okay. So this length is dx. This length I call it as dx. Having mass how much? Dm, isn't it? So look over here from this side, since the liquid is thrown backside, some pressure is applied, and that force will be pressure into A, isn't it? But here, due to the pseudo force, dm into acceleration A, the net force applied from that side is increased, that is P into P plus dP into area, isn't it? Net pressure will be increased from the right side or not? From the left side. So the equation becomes what? Net force is still zero. So this is P plus dP into area A minus P into area A minus dm into acceleration A is equal to how much? Zero. So equation is PA cancel. So dP into area A is equal to dm into acceleration A. dm is dP into area A. dm is density into volume. Volume is area into length dx into acceleration A. A cancel. Find the pressure difference equal pressure from point A to point B. And if I just consider that the reference point A, the net pressure is how much? Zero. P at A is how much? Zero. Or okay, let us consider that pressure to be P. I consider that pressure to be equal to how much? P. Okay, so the equation becomes simple. Pressure at B minus pressure at A is equal to rho into acceleration A, and integration of dx is from 0 to L, isn't it? So rho L into A. That's your formula. Initially it was PB minus PA for depth, is rho GH for depth. For acceleration it is rho LA. Means in horizontal level it is rho LA. Okay. Where rho is the density of liquid. Is that clear or not? Can we move to another point? Now you know that pseudo force can also be brought with the help of rotation. So you can find some pressure difference with respect to rotation also. So let's suppose if I consider any kind of a container, in which some liquid is filled up, and I'm rotating this container with some angular velocity omega. Okay, then if this is point A and this is point B and length gap is length L, then find PB minus PA. Do it fast. Mhm. Yes, moment of inertia, not with moment of inertia, but center of mass definitely. Do it fast. Mm-hmm. No use of center of mass. Yes. Mm-hmm. Mm-hmm. Okay. Let us take. Yes, it's kind of correct. Yeah. So look over here. Same thing. We can consider a small mass element, isn't it? I think. Yeah, correct. Now it can be done. Now you've got the idea, isn't it? So simple. Dx, dm, located at distance x, isn't it? Now, centrifugal force will pull the body towards the right side. So at B, pressure will be higher once again, isn't it? So from here, let's suppose the pressure that is built up is PA into A. P into A. How come it will be P plus dP? Pressure is developed from A side. B side it is more or not. Pseudo acceleration is towards this side. So let's suppose it is Gm. The pseudo force is dm omega square x, isn't it? So here the pressure will be more. P plus dP into area. The force will be P plus dP into area, isn't it? So equation will once again become P plus dP into area I minus PA minus dm into omega square x. Yeah, so dm omega square x. dm, we need to put first dm. Dm is what? Density of the liquid rho. Hmm. So a cancel, integrated from A to B. Now at A, what is my pressure? Some pressure will be developed, isn't it? But the coordinate will be 0 over here. So 0 to length. So this becomes PB minus PA half rho omega square L square. है कि नहीं? Yes. अब मान लेते हैं कि अगर मान लो दो पॉइंट्स के बीच मींस दिस A is present at some coordinate L1 and this B is present at coordinate L2. कहाँ पर present है? L2. Then PB minus PA is nothing half rho omega square L2 square minus L1 square. Is that clear or not? So we got to do so many cases of pressure differences and all, isn't it? Agree. Still, there are so many things are left, but once again, we'll pick it up tomorrow evening. Okay. Tomorrow I might take a long class of fluid also. Still, it's not half; it's just the 30% which we were able to finish today.